before we do any other examples, let's try to come up with a name. Let's give this a name, and let's make it an official technique that we can use in general for stuff of the form x squared plus bx. And let's try to think about this visually. What we want to do is we want to add a square to the square x squared when we have this material as well in order to make a new square. So how could we sort of visualize this? Well, suppose visualizing x squared is easy, right? It would just be some square of size x where this is the area x squared. And I want to add a square here to make this into a bigger square. So I would need these two sides together to represent bx. This plus this is bx. So what does that mean? It means that each of these areas has to be half of bx. So this is 1/2 of b, and this is 1/2 of b. Why isn't this bx? Because this is already x, so that's going to give me 1/2 bx for this area, 1/2 bx for this area. So together, these three areas give me x squared plus 1/2 bx, 1/2 bx, together 1 full bx. So all I have to do is find out what the area of this piece is, and I will have a perfect square. So what is this area? Well, this is 1/2 b, and this is 1/2 b. So together, I get an area of 1/2 b squared, or b over 2 squared. So this is the thing we need to add. So it's a nice sort of geometric way of seeing it. It even tells us exactly what we're going to get when we're done, because this is going to be x plus b over 2. This is x plus b over 2. So once we're done, we're going to get x plus b over 2 squared. Of course, we're going to have to compensate because we added the b over 2 squared with a minus b over 2 squared. But let's write this all out as a method. So we're going to call the method, since we took this and we found a piece to complete the square, we call it completing the square. So for something of the form x squared plus bx, we can use this method. Maybe all we have is x squared plus bx. Maybe we're setting it equal to a constant. Maybe we're doing something else. But we can use this technique that we just displayed geometrically. And what does that technique give us? Well, let's write out the steps. What we're going to do is we're going to add and subtract b over 2 squared. Then we're going to group the first three terms to get, and what's that going to give us? Well, like we said before, x plus b over 2 squared. And then we have this minus b over 2 squared that we will have to maybe group in with something else. But this is it. These are the whole. This is the whole method of completing the square. So, for example, if I have x squared plus 6x, what do? Well, I add and subtract b over 2 squared. So what's b over 2? b over 2 is 3. b over 2 squared is 9. So I'm adding and subtracting 9. I'm adding and subtracting b over 2 squared. But what does that give me? Well, now I look here, because when I group these first three terms together, I get x plus 3 squared, and I still have the minus 9. And if all I want to do is complete the square, I'm now done. If I wanted to set this to 0, then I'd have another step where I move the 9 over, and then that trick for radicals comes into play. Suppose I had x squared minus 6x, and I wanted to try this technique. Well, I add and subtract b over 2 squared. Here, b over 2 is negative 3. And b over 2 squared is 9. I get this. And when I group these three terms together, I get x plus b over 2 squared minus 9. And now this is in a form where I can easily set this to 0 or whatever constant I had to set it to. So this is our method. We call it completing the square. And now, going on, let's look at some examples of completing the square with equations.